Hello ladies, gents, and everyones. It is Thursday, June 9th, and we're here to talk about this week's space and astronomy news. Actually, it might be June 10th by the time you see this, because I don't know if I'm gonna get this edited today. Trusty old Perseverance rover has been driving around the Jezero crater on Mars for over a year now. The rover has even started taking samples that will later be collected by the NASA ESA Mars Sample Return mission. And now Perseverance has reached its final destination, the reason that Jezero crater was chosen as the landing site, and that is an ancient river delta. This billion-year-old delta deposited layers of sediment on the floor of the crater, and these types of sediment here on Earth would be just teeming with life, so this is a really promising place to look for signs of ancient life on Mars. Perseverance will be taking several samples of these very exciting rocks, but for the moment it's actually just traveling and investigating. This allows scientists here on Earth to actually pick the best places to take the samples, because Perseverance only has 43 sample tubes and only about 30 of those are expected to ever make it back here to Earth. And during this exploration, Percy might have found a great place to deposit its first cache of samples. This actually wasn't really planned to happen yet, but this is such a great place that they found that the team is really strongly considering it. Now, we won't have our hands on these samples for at least another decade, but it's really exciting to see this happening and to learn more about Mars. Last week we talked about how we monitor these near-Earth objects for planetary defense, but Earth is not the only planet that gets impacted by small bodies. Jupiter, being a rather larger target, actually gets hit much more often and with much more energy. In fact, these Jupiter impacts can release so much energy that they're visible as optical flashes that can actually be seen by amateur astronomers here on Earth. This actually happened 6 times between 2010 and 2020, but all of those detections were just lucky chance. Enter PONCOTS. PONCOTS is a small telescope that is dedicated to surveying just for these impact flashes on Jupiter. And after it started monitoring in September of last year, it took only a month to detect a really large optical flash in October. Because PONCOTS is a dedicated telescope, it was actually able to resolve in time the optical flash in 3 different wavelength bands, giving us a much better measurement of the energy of the event. And the energy from this impact was about 2 megatons of TNT. That's huge! That's about the same as the famous Tunguska event that impacted Earth back in 1908. And it's the most energetic impact we've seen on Jupiter since the famous Shoemaker-Levy comet impacted Jupiter back in 1994. From this detection, scientists can infer that impacts of this energy probably occur about yearly on Jupiter, and studying the flashes can help us learn more about these decameter-sized bodies. Speaking of impacts, there's one that's been all over the news this week, but on a much smaller scale. That's right, I'm talking about the James Webb Space Telescope getting hit by a micrometeorite. Don't worry, the telescope is still operating well above its engineering requirements to meet its mission. Now, it was unavoidable that the telescope was going to have to deal with the environment of space, which includes small dust particles traveling at really high velocities. Over time, these sorts of impacts can degrade the performance of the telescope and were taken into account when designing the telescope. In fact, Webb already had 4 micrometeoroid strikes prior to this one that were large enough to be detected but too small to cause any damage. Now, this latest strike is slightly larger, and in fact it's larger than even what NASA's predictions had assumed. This strike occurred on one of the primary mirrors and did have a very tiny but marginally measurable effect on the telescope's data. But like I said, still working better than fine. This larger than expected strike will help the team refine their estimates for the performance of the telescope over time and can even help us learn about the dust environment of the solar system. And none of this will affect the release of JWST's first full images, which is going to happen in 33 days. It's been over 3 months since Russia invaded Ukraine, and the war is still ongoing. The international community responded very negatively to Russia's aggression, leading Russian officials to make statements casting in jeopardy the continued cooperation on board the International Space Station. Now, however, Roscosmos is walking back those claims. This past weekend, the Director General of Roscosmos stated that Russia would keep working until 2024, which is the end of the current operating agreement, and would provide at least a year's notice prior to ending operations on the ISS. Of course, the US has stated the intention to keep the ISS operating through 2030, so TBD if Russia will sign on to that extension. Although worth noting that their planned space station, the Russian Orbital Service Station, will not be in operation until no earlier than 2026. And when it comes to the US getting to the International Space Station, while Boeing did take a step forward last month in completing their cargo test mission, they still aren't ready for crew certification. So NASA released a notice last week that they will be purchasing an additional 5 flights from SpaceX, who is crew certified. These 5 new flights, in conjunction with the previously purchased flights from SpaceX and Boeing, will support operations of the ISS through 2030. Galaxies are made up of stars, but those stars in other galaxies are really hard to see. So for a long time, astronomers just kind of had to assume that the stellar populations in other galaxies were similar to those of the Milky Way. But a new study published last week in the Astrophysical Journal is providing evidence to the contrary. The team looked at 140,000 different galaxies to try and measure the initial mass function, or IMF, of the stars. The IMF quantifies how many stars of a given mass are formed. Now, the team was not able to actually measure individual stars in all of these galaxies, but they were able to infer the IMF by looking at the color of the galaxies as a whole. They found that stars in distant galaxies tended to be more massive, and that the farther away you go, the more massive the average star becomes. This is some of the first observational evidence for a variable IMF and could help us learn more about stellar formation and how galaxies evolve and die. One thing I love about astronomy and astrophysics is how much we don't know. I mean, don't get me wrong, we've come a very long way since people first started painting stars on the walls of caves, but there's just so much left for us to learn. Recently, scientists found a new type of neutron star that they can't really explain. Because this neutron star is a pulsar, astronomers can measure its rotational period very accurately, and they found it to be about 76 seconds. Now, just over a minute doesn't seem like all that long for an object more massive than the sun to spin entirely around, but similar pulsars actually have periods like fractions of a second. Now, those types of millisecond pulsars do spin down over time. That is, their spin becomes slower, so their periods get longer. But along with that spinning down, they usually stop emitting radio waves. But this neutron star, despite its very long period, is still creating radio emission. Also, this object was very difficult to detect, which means it could be a part of a much larger population that we just don't even know about yet. This discovery throws into question our understanding of radio emission and spin evolution in neutron stars, and is just a great example of how many mysteries there are left to discover in the universe. Thank you so much for watching. I hope you enjoyed, and I will see you again in probably 2 weeks.